Hello, users. So today I will explain about the one HLD case study. So I will take one example of online code judge software, right? Let's take one example. Let's take in one example of online DSA contest, right? So in the DSA contest, for example, there is 1 lakh users. I mean 1 lakh participants, right? And the duration of a contest is 3 hours. And in the contest, we have 5 problem, right? So let's write it here. So online code judge software. You can take example of lead code, right? And we are specifically talking about the DSA contest. DSA contest. So let's take a roughly estimation of traffic first. So for example, we have 1 lakh participant, right? And we can assume that every participant like uh, make 5 evaluation uh, in the duration of 3 hours, right? On an average, let's assume that every participant like evaluate 5 submission, right? So the total number of submission over the contest is 5 lakh. So 1 lakh into 5. So total submission is 5 lakh. Now I have to calculate every second, like how many submission like online codes that software have to take. So total number of submission is 5 lakh. So submission per second is 5 lakh divided by, so 3 hour of contest is there. So 3 into 360, right? And we can say it's around 10,000, right? So we can remove this for here. So total. So in the online code judge software, we have to evaluate 50 submission per second. Right? Now, so and let's say for every submission, server will take 10 seconds to execute because there are lots of test cases, right? So app server needs some time. So let's say every submission son- take every submission take 10 seconds of time. All right. Now let's say how many server we required to evaluate to support this kind of estimation. So we need 500 servers. How I am come up with this 500 server? So for example, for the first second, how many we submission request we are getting? 15, right? Now how many time required for every submission is 10, right? So total how many server required? 500, sorry, 10 So 50. So every submission request we have to run in the separate server. So total 50 server required. Now for the second, when the second seconds, again 50 requests come, right? At that time, the earlier previous 50 server are still busy because every submission required 10 seconds to run the uh, submission, right? So again we required the 50 server. So in the, so at the end, at the like 10th second, we required 500 server. Then at the 11 second, there are the server which is occupied at the first second will be released because it is 11 second and 10 second is elapsed, right? So now the existing server will be used. So in total we have to put 500 server to support the online code search software, right? Until now we are clear. So every second there are 50 submission we have to support, and for that we need the 500 server, app server, right? Now let's draw the diagram how the architecture will look like, right? So let's write 50 submission per second, right? So there are user is there, right? Now there is one load balancer in front of every server, load balancer, right? Now request come to load balancer will transfer it to online coach code judge app server. So there are 500, sorry. So this is code judge app server. Yeah, one point I have forgot to told that we cannot use multi-threading. You are thinking like instead of using the 500 server, let's use the multi-threading, so we can leverage the less number of server. So that idea will not work because here the execution of code is uh, not IO bound task, it is CPU bound task, right? So threading will not help here, right? So if we have the IO bound task, then and then we have to use the multi-threading here, right? So that point I have to highlight. Okay, now this is code judge app server. Now load balancer will transfer request to the one of the uh, code judge app server. Now uh, we have two databases. One is S3 database, and one is the one relational database, for example SQL. So in the S3 we will store the test cases, static test cases, and in the SQL we store the all the information of user, contest, and participant, okay, in the SQL. Alright, so in that way we have to like prepare this kind of architecture for the online course software. Now let's say what information required for the every submission. For example, so in the request what we will get is user ID, user ID, problem ID, contest ID, and the code, right? That will come from the request itself. request. All right. Now at the app server, what app server will fetch it? So app server will fetch the user information, problem information, contest information, that is from the SQL, right? So from the SQL, what we will store is user info, like problem info, and the contest info. All the info we will store in the SQL itself, right? And another thing which require app server is the input and expected output of the code, right? Which we can say the test case file, right? So we will store the test case file into the S3. Why we have to store? Because test case file is very used. So if I'm take one real world example, then every test case is around 1 GB of data, because it has lots of data, right? So every test case has 1 GB of one every test case required 1 GB of storage. So we cannot store this kind of very static and blob file into the SQL. So that is why we have to store into the S3. Now the bottleneck is, so every second we have 50 submission, and every submission we have to load test case file from the S3 to the app server, which is 1 GB of 1 GB of test case file, right? 1 GB of test case file. So it will be a bottleneck, right? For the every second we have to load 50 GB of data from the S3 bucket to the app server. So that will be not feasible, right? So so the answer of this problem is caching, right? So we have to use caching somewhere. All right. Now uh, so now the next question is, what type of caching we can use, and what cache invalidation and cache eviction policy we can use, right? So first, what type of cache we can use? So there are two type of caches. One is global. So in the global as well, we have two types of cache. One is the single, and second is distributed. Now and the local cache. So out of them, which we can use? So let's think, like, if we use the global, then what will be the problem? If we will use the global case, for example, here, if we use one global case, then again the bottleneck is same. We have to load the 50 GB of data from the global cache every second. So again the problem is same, so it will not resolve our problem, so we cannot use the global, right? Now let's take, if we use the local cache instead of the global cache. So local cache will reside at the app server level, so it would be the either RAM or hard disk, right? So we can cache the test cases in the local cache, so it will work, right? Because the test cases are present in the local cache, mean the RAM or hard disk. So out of them, we can, which storage we can use? So as I already told, that every test case file is 1 GB, and if we said that only 30 to 40 problem are the most used problem, right? So we can say we can keep the 30 to 40 test case file into the local cache. So RAM will be, if we use the 30 test case, then the total cache storage that will be a 30 GB, right? So we cannot store this 30 GB of data in the RAM, because the RAM memory is very small, right? So we can we can store instead to the hard disk. Sorry. So the hard disk is the here the good option for the local cache. Alright. Now how uh, we have designed the flow, like let's one take example how actually the request will flow. So whenever user request for the submission of the code, so request come to the load balancer, load balancer will transfer the request to the one of the app server, right? Now app server will check if the test case file is present in the app server. So for the first time it will not present. So what it will do, it will load it from the S3 bucket itself and store into the local cache. Alright, for example, problem one underscore input dot txt. Alright, it will store into the local cache and it will evaluate the submission, it will respond the result, right? Now again, the next time if the request goes to the same app server here, then the problem are already there, the problem test case are already there, so it will not load from the S3 bucket, it will use the local cache instead, right? So in that way we can solve the problem of the high load the data of problem, right? Now so this is the flow. Now again we have to discuss the cache invalidation and cache eviction policy, right? So let's take one example, let's discuss about the cache eviction policy. So since the local cache is limited, right? So hard disk storage is limited, right? And there are lots of problem are there, for example 5,000 problem we have, so it's require 5 TB of hard disk, so it will be impossible, right? So we have to remove some cache, right? So we can use the LRU cache policy, least recently used. So whenever new test case file we have to store, we have to remove the test case which is least recently used. So the LRU will work. No need to discuss anything in the eviction policy. Now the important thing is cache invalidation policy. So let's take one example. My DSA contest is started and one of the participant come up with the query that one of the test case is wrong, right? So we have to immediately correct that test case and upload it to the S3 bucket, all right? So at the same time we have to update into the all the local caches of the app server, understood? So it will be a immediate, right? If we update anything in the test case file, then it should be update automatically to the all the server. So that is the must requirement, but because that scenario will come, right? There will be a any wrong test case written by the any support system, right? So we have to support this kind of immediate action, right? Then how we will achieve in this case, right? So there are multiple cache invalidation policy. So let's take one example. For example, so there are 4 to 5 most popular cache invalidation policy. So there is one, first one is TTL, time to live. Second is uh, cache around, cache through, and one is cache back, cache back. Sorry, cache back. Let me write it here. Cache, CACH, cache B, cache back. So in the TTL and the cache around, it will be a not immediate consistency, right? It will be using the TTL and cache around. We can use we can achieve the eventual consistency, but here we require the immediate consistency. It will, what I mean to say is, here we need to support immediate update of the test case file to the app server file, but in the TTL and in the case around we cannot achieve that. You can refer my another video for the cache invalidation policy, where you can find what is the TTL and cache around, right? So from the TTL and cache around, we cannot, it cannot support the immediate consistency. So cache through and cache back support the immediate consistency, but out of two, which we can use? So in the cache back, so what we can do is the cache back. So we can store the test case file first into the cache, right, and the later on to the actual database. But here we have 500 server, so if we have to update the test case file to the every 500 server, it is impossible, right? So we cannot use the cacheback, and there is a chances of data losses, right? So we cannot use the cacheback invalidation policy here. The other option is cache through. So in the cache through, we will update the, we can update the test case file in the database as well as in the case at the same time, right? So we can use the cache through, that is perfect, right? But if we update the test case file, like how we can update the test case in the database as well as the cache itself? So first, let's say we have updated the cache file in the S3. Now it's time to update in the all server. So we can use the two-phase commit, two-phase commit here. But don't you think updating the test case file in the 501 server is impossible, right? Using the two-phase commit, because there is a chance that one of the app server is down, right? So the two-phase commit will be a fail, right? So we cannot use the two-phase commit here. So what are the other solution we can use? So uh, that is the important thing. So we can use the versioning here, right? What do you mean by versioning? So uh, for example, if there is changes in the test case file, right? So in the let's draw one problem table from where you can. So there is one problem ID here, there is one number of test cases, and another is file name, test case file name. For example, one, so number of test cases is 20, and the file name is p1 underscore input underscore v0.txt, right? So there is one entry in the database itself for the problem and its test case file name. Now if some user requested to update some test case, then we will update the test case in the S3 bucket first. So we will update the S3 test case in the S3 bucket first, then we will change the file name of the problem. We will change file name from p1 input and v1.txt. Here we have changed v0 to v1. So in that way, right? So in that way we can use the immediate consistency. How it will work? So for example, now again user requested user requested for the p1 submission. So there is in the database itself, there is the older file, right, which is v0. Now so in the database itself there is p1 file, so again it will not use the older file, so it is a stale file, right? So like app server will not use the stale file, it will use the new updated file here from the that is v1. So it will again load it from the s3. So using in that way we can use the in that way we can achieve the immediate consistency here. Got it. So that is all about code, online code judge software design. So if you like this video, if then please like my video and subscribe my channel. Thank you.